Hi dear students, welcome to the classes. Next we will start on the next concept in the D block chapter. The D block chapter we are going for the magnetic moment. We are going for the magnetic property of the D block elements or transition element. D block element transition are also called as transition element. Okay, you see here magnetic moment or magnetic property. I already make one separate video in solid state chemistry. ನೋಡಿ ನಾನು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಕೆಮಿಸ್ಟ್ರಿ ಬಿಡಿಸುವಾಗ ಅಥವಾ ನಾವು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಸಾಲಿಡ್ಸ್ ಅಂತ ಹೇಳಿ ಒಂದು ವಿಡಿಯೋ ಸಪರೇಟ್ ವಿಡಿಯೋ ಮಾಡಿದ್ದೆ. ಆ ಸಪರೇಟ್ ವಿಡಿಯೋನ ಒಂದ್ಸತಿ ಪ್ಲೀಸ್ ಈ ವಿಡಿಯೋ ಇದನ್ನ ನೋಡೋಕ್ಕಿಂತ ಮೊದಲು ಅದೊಂದ್ಸತಿ ಅಬ್ಸರ್ವ್ ಅಥವಾ ನೋಡ್ರಿ. ದಟ್ ಈಸ್ ವಾಟ್ ಮೈ ರಿಕ್ವೆಸ್ಟಿಂಗ್. ಫಸ್ಟ್ ಯು ಗೋ ಫಾರ್ ದಟ್ ಗೋ ಥ್ರೂ ದಟ್ ವಿಡಿಯೋ, ದೆನ್ ಗೋ ಫಾರ್ see this one. Otherwise no problem, I will remember some points in that. What is that magnetic moment or magnetic property? I explained that magnetic property in ಯಾವುದಕ್ಕೆ ಇರಲಿ, ಈ ಒಂದು ಯಾವುದೇ ಒಂದು ಅಬ್ಜೆಕ್ಟ್ ಐತಿ, ಒಂದು ಯಾವುದೇ ನಂದು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಡಸ್ಟರ್ ಈ ಡಸ್ಟರಿಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಬರ್ಬೇಕು ನಮಗೆ. ಈಗ ಈ ಪ್ರಾಪರ್ಟಿ ಬರಬೇಕು ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ನಿಮ್ಗೆ ಗೊತ್ತು, ಅಯಸ್ಕಾಂತ. ಇಟ್ ಕ್ಯಾನ್ ಅಟ್ರಾಕ್ಟ್ ಸಮಥಿಂಗ್ ಎಲ್ಸ್, yes right, or it can be repel something else, and it is having some property of magnetic lines of force or like this. Therefore ಈ magnetic property ಬರಬೇಕಂದ್ರೆ what are the reasons, what is the importance or what is important carrier points for that magnetic, what are the natures of magnetic property, that I will tell you. ಒಂದು ಯಾವುದೇ ಒಂದು ಅಬ್ಜೆಕ್ಟಿವ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಬರಬೇಕಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯು ಸಿ ಹಿಯರ್ this is what electrons are revolving around the nucleus. This is what you see here. One minute before that I will tell you, you will not go for the excess. This is what the nucleus, in this nucleus electrons are revolving. Yes, electrons are revolving. The magnetic property I explained in that electrons are revolving around it. The electron itself revolving. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ ಇದನ್ನ ಎಲೆಕ್ಟ್ರಾನ್. ಈಗ ನಮ್ಮ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಬಿಕಾಸ್ ಆಫ್ ಡ್ಯೂ ಟು ಟೂ ರೀಸನ್. ಒನ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ಡ್ಯೂ ಟು ದ ಎಲೆಕ್ಟ್ರಾನ್ ಇಟ್ ಸೆಲ್ಫ್ ಸ್ಪಿನ್ನಿಂಗ್. ಆ ಎಲೆಕ್ಟ್ರಾನ್ ತನ್ನ ಸುತ್ತ ತಾನು ತಿರುಗುವುದರಿಂದ ಒಂದಾದ್ರೆ, ಇನ್ನೊಂದು ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ತಿರುಗುವುದು. ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ವಿತ್ ಇಟ್ಸ್ ಸ್ಪಿನ್ನಿಂಗ್. ನೋಡ್ರಿ, ಇದು ತಿರುಗ್ಕೋತ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತೊಡೆಯುವುದು. ದಿಸ್ ಇಸ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ಎಲೆಕ್ಟ್ರಾನ್. The magnetic moment of any substance or any solids is because of due to its spinning up electron. Spinning up electron is one reason, and one more is the electron is spinning around itself and its orbital. The electron, the magnetic moment of any object is because of due to its orbital motion as well as the spinning up electron. Therefore the first magnetic moment is because of due to spinning up electron. Spin of an electron. ನೋಡ್ರಿ, the reason for magnetic moment, ಯಾವುದೇ ಒಂದು ಅಬ್ಜೆಕ್ಟ್ ಆಯ್ತು, ಯಾವುದೇ ಒಂದು ಸಾಲಿಡ್ ನಮಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ತೋರಿಸ್ಬೇಕಂದ್ರೆ ಫಸ್ಟ್ ರೀಸನ್ ಇಸ್ ಸ್ಪಿನ್ನಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್, ಅದರ ಸುತ್ತ ತಿರುಗೋದು. ನೆಕ್ಸ್ಟ್ ರೀಸನ್, ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಈಸ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂಡ್ ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್ ಥ್ರೋಡ್ ದಿ ಆರ್ಬಿಟಲ್. ನೋಡ್ರಿ, ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದು ಸುತ್ತಗೋತ ಆರ್ಬಿಟಲ್ ಸುತ್ತ. therefore the electrons movement throughout this orbital. Next point is orbital motion of electron. Therefore these two reasons are helps for the magnetic moment, magnetic property. From this I will tell you any solids in that I was discussing D block element. All D block elements showing magnetic moment or magnetic property. That magnetic property is because of due to two reasons. One is a spin up electron, the spinning up electron, and one more is orbital motion. It is revolving and around it is revolving around the nucleus. Therefore from these two reasons the many D block elements showing the magnetic moment. In that magnetic moment I discussed 2 points, and that I will go for that paramagnetic and one more is called as diamagnetic. What is meant by paramagnetic and diamagnetic substances? After that I will go for the paramagnetic and diamagnetic substance. What is meant by paramagnetic substance and what is meant by diamagnetic substance? Paramagnetic, you dear one, all you see here, paramagnetic substance means one thing, they are attracted by magnetic field. Attracted by magnetic field. Attracted from magnetic field, and they are repelled by. They are repelled by magnetic field. Nodri, ಯಾವ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಗೆ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೋತೇವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು ನಮಗೊಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಐತಿ, ಇದು ನಾವು ಇಲ್ಲೊಂದು ಏನಾರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಟ್ಟೇವೆ ಅಂದ್ರೆ ಇದನ್ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೋದು. ಇಲ್ಲೊಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಟ್ಟರೆ, ಈ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಹ್ಯಾಂಡ್ ಇಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಇದು ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಇದನ್ನೇನ್ರ ಇದು ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೋತಂದ್ರೆ ದಿಸ್ ಇಸ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. If it is repelled, then it is called as diamagnetic substances. The paramagnetic substance means they are attracted by magnetic field, and diamagnetic substance means they are repelled by the magnetic field. One more thing, paramagnetic substance means they are having unpaired electron. Unpaired electron. And next, diamagnetic substance means no unpaired electron. No unpaired electron. You see here, the paramagnetic substances are those they are attracted by the magnetic field because they are containing unpaired electron. What is meant by diamagnetic substance? Diamagnetic substance means they are repelled by the magnetic field and they does not contain any unpaired electron. That is very important yesterday. Okay, from this we have go for that all d block elements. All d block elements outermost n-1 d orbital d electron, right? All outermost d1 to d10 is there. All d block elements containing d1 to d10 electron, they are unpaired electron, right? Therefore, for example, d1, d2, d2, d3, their outermost electronic configuration. All outermost electrons are incompletely filled. Incompletely filled means they are containing unpaired electron. Therefore, all our d block, almost all, not all, almost all of our d block elements are act as a paramagnetic nature, and that's why these d block elements are showing the magnetic nature. Okay, next in your examinations they are asking more questions. What is that? I will go for that. I hope from this you can understand the what is mean paramagnetic and diamagnetic. After that, how to calculate this magnetic moment, total magnetic moment? The magnetic moment is because of due to spin up electron as well as due to orbital contribution. Okay, magnetic moment is calculated by the formula mu. The magnetic moment, therefore the magnetic property, that magnetic moment, the magnetic moment is denoted by the mu. The mu is given by totally 4 into 4 s into s plus 1 plus l into l plus 1. You see here, dear students, the total magnetic moment, that contribution is l plus s. What is this magnetic moment l plus s? The total magnetic moment is because of due to spin up electron plus orbital contribution. Orbital contribution. You see here, whenever just ಏನು ಹೇಳಿದೆ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ತೋರಿಸಬೇಕಾದ್ರೆ ಎರಡು ರೀಸನ್, ಒಂದು ಸ್ಪಿನ್ ಮತ್ತು ಇನ್ನೊಂದು ಆರ್ಬಿಟಲ್ ಕಂಟ್ರಿಬ್ಯೂಷನ್. ಯು ಸಿ ಹಿಯರ್ ದ ಟೋಟಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 4s into s plus 1 plus l into l plus 1 ds. Okay, ಈಗ ನಮಗೆ ಇದು ಟೋಟಲ್ ಆಂಗುಲರ್ ಮೂಮೆಂಟ್. If orbital contribution is not there, means then l equal to 0. Next, we know that a spin up an electron is given by n by 2. What is the spin? The spin up electron is equal to the contribution of the, what is meant by n? N means number of unpaired electron. Therefore, spin up electron, this spin is given by n by 2. Therefore, we have to substitute these values, s equal to n by 2. Next, l equal to 0 because there is no any orbital contribution. Therefore, mu equal to square root of 4 into here S equal to n by 2. Therefore, n by 2 divided by n by 2 plus 1, dear student. After that, we will take this LCM. It is going to the here 2, this one. This here the control square root of 4 into next you see here, this is what mu equal to 4 into n. Wherever this s is there, you have to substitute n by 2 and l equal to 0 because there is no orbital contribution. Next 4 into n by 2, 4 here, 4 into n by 2 square root of n by 2 plus 1. Next, after that we take simplification. I think it is not very clear here. Okay, after that you see here, this is what I will write here. Next, after that 4 n by 2 here, LCM n plus 2 divided by 2, 2 into 2 4, therefore is cancelled here. Then after that this formula becomes n into n plus 2. The unit of this one is Bohr magneton. The Bohr magneton. Okay, you see here, yes, this is a formula for finding the magnetic moment, only spin contribution. The only spin contribution, there is no any orbital contribution. They are asking the questions on only this formula. You have to remember this formula, mu s equal to square root of n into n plus 2. Most of the students are confusing square root of n into n plus 1, they are writing. It is not 1, it is 2. Okay, go for some example. Go for the Fe2 plus. What is the Fe2 plus? How they are asking question? Calculate the magnetic moment for the Fe2 plus ion. Okay, we know that Fe electronic configuration is argon 3d6 4s2. Argon 3d6 4s2. After that we are calculating for Fe2 plus. Fe2 plus means outermost we are removing 2 electron. Therefore, the formula becomes argon. The electron configuration becomes argon 3d6. Okay, how many number of unpaired electrons in this one? Go for the box diagram. This is what a D block D group elements. That outermost 6 electrons. First we have to fill the electrons singly. We know that this is one rule in that. And after that there will be 5 electrons. Fill one more electron. Therefore there are 4 unpaired electrons. You see here, this is paired electron. These are paired electron, but this is not paired. Therefore totally how many unpaired electrons? Therefore totally n equal to 4. This is what number of unpaired electrons. Next, unpaired electrons is 4. Next, we have to substitute this 4 in this one. Therefore, mu equal to square root of 4 into 4 plus 2. Therefore, square root of 4 into 6. Square root of 4 into 6 means 24. Therefore, this answer is around 4.9. Bohr magneton, dear student. This is what we are solving the problems. That 2 marks question is compulsory. They are asking, and 2 marks question is compulsory. Go for the next one more problem. Mn2 plus. Calculate the magnetic moment for Mn2 plus. Now first write the Mn electronic configuration. What is that Mn electronic configuration? Argon 3d5 4s2. If you don't know how to write the electronic configuration, I given the description in the description box. See the how to write the electronic configuration. I make one separate video on electronic configuration. Okay, Mn2 plus electron configuration, argon 3d5. Outermost 2 electrons were removed, it becomes 3d5. Next, go for the box diagram. How many number of unpaired electrons are there? There are 5. 1, 2, 3, 4, 5. Therefore, all electrons are singly filled. Therefore, n equal to 5. Therefore, substitute mu equal to square root of 5 into 7. 5 n plus 2 means 5 plus 2 7. Therefore, square root of 35. Square root of 35 means is around it will be how much? Square root of 36 means around 5.991 something Bohr magneton it will comes. Around 5.9 or 5.89 it will comes. Go for the calculation. This is what calculations. We will solve one more problem. So we will solve one more. Then we are going to understand the electron configuration. Okay, go for the chromium plus. Chromium cross. Chromium electronic configuration is argon 3d5 4s1. This is what electron configuration of chromium. If you are removing chromium 1 electrons, means the electron configuration becomes argon 3d5. Argon 3d5. This is outermost. How many electrons are there here? Outermost 5 electrons. You see here 1, 2, 3, 4 and 5 valence electron. Therefore again mu equal to square root of 5 into 7, means it is around root of 35 Bohr magneton. If instead of chromium 1, if they are asking chromium 2 plus, if chromium 2 plus means what is that answer? Chromium 2 plus means the argon. Next, here 2 electrons we have to remove from chromium. 1 electron from this one. Next electron 3d4. Therefore, chromium 2 plus electron configuration argon 3d4. Next, how many number of unpaired electrons? Go for the calculation. Therefore, 1, 2, 3, 4. Therefore, these 4 are singly filled. Therefore, n equal to 4. Then after that, mu equal to square root of 4 into 4 plus 2. Therefore, square root of 4 into 6 means 424. Therefore, mu equal to 4.9 Bohr magneton. This is what calculating Bohr magneton. There are so many questions they are asking in this. Okay, please read this calculations perfectly and next solve the problems. For this I will give one what I solved, that one I will give one book. I will give, I am solved some problems, I will give you that. Okay, see here dear friends, one thing I will tell you, if chromium 2 plus and chromium 3 plus is there, what is the magnetic moment you have to calculate and compare. If argon, chromium 2 plus means argon 3d4 electron configuration, chromium 3 plus means argon 3d3. Unpaired electrons here 4, here unpaired electrons is 3. The magnetic moment calculation after substituting n equal to 4 in this one, it goes to around 4.91. I am rough calculated, I am here 4.91 Bohr magneton. Here mu equal to 3.87 Bohr magneton. You see here n equal to 3, n equal to 4. If number of unpaired electron increases, the magnetic moment value also increases. The number of unpaired electron increases, the magnetic moment increases. Therefore, the magnetic moment is directly proportional to number of unpaired electron. Therefore, we conclude that the paramagnetic nature of any component, the paramagnetic nature or attracting power of any solids or metals is directly proportional to its number of unpaired electron. If number of unpaired electron is more, then for its paramagnetic nature is more. They are asked this one for Neet, that's why I am explaining this point perfectly. The number of magnetic moment is directly proportional to unpaired electron. Therefore, in this chromium 2 plus is more magnetic nature compared to chromium 3 plus. Okay, you solve plenty of problems writing the electron configuration. Now calculate the number of unpaired electron, substitute in this, you are getting the answer, and at last you have to write the Bohr magnetic. If you are not writing the unit, you are losing 1 marks. Solve plenty of problems, dear students. Thank you for watching my video. If you don't, I am planning to do one separate video on this Bohr magnetic calculations. Okay, thank you for watching my videos. If you like my video, please share and subscribe. Thank you.